Welcome to the DIY Honda Garage channel. DTC P011A indicates a malfunction within the Engine Coolant Temperature (ECT) Sensor 1 circuit of the Honda Accord models from 2012 to 2017. The diagnostic trouble code signifies a performance issue, prompting the Powertrain Control Module (PCM) to flag this error for further investigation. This is crucial, as the ECT sensors play a key role in engine management by providing the PCM with essential temperature data of the engine coolant and intake air. Specifically, this vehicle is equipped with 2 ECT sensors and 1 intake air temperature (IAT) sensor, which collaborate to ensure optimal engine performance. If the temperature readings from these sensors do not align correctly, it can lead to inefficiencies in engine operation, affecting fuel economy and emissions. Diagnosing the faults associated with this code is critical to maintaining engine performance and reliability. The DTC P011A is primarily associated with Engine Coolant Temperature Sensor 1, along with the ECT Sensor 2 and the Intake Air Temperature IAT sensor. These sensors are interconnected and provide crucial data to the Powertrain Control Module (PCM) for accurate engine performance evaluation. The ECT sensors are generally located in the engine bay, directly interfaced with the engine coolant, while the IAT sensor is positioned in the intake manifold to monitor the temperature of air entering the engine. The PCM compares the readings of ECT Sensor 1 with ECT Sensor 2 and the IAT sensor. If discrepancies arise, particularly after the engine has been off for an extended period, the PCM interprets this as a malfunction, triggering the DTC P011A. It is essential to understand that accurate temperature readings are vital for effective engine management, affecting everything from ignition timing to fuel injection. Several factors can lead to the triggering of DTC P011A, each of which plays a significant role in the vehicle's overall functionality. The primary suspect is a failure of ECT Sensor 1, which could be influenced by corrosion or internal defects, leading to incorrect readings. Additionally, ECT Sensor 2 could also be at fault, resulting in a discrepancy when compared to ECT Sensor 1. The IAT sensor can also cause issues should it fail, as it provides crucial data about the incoming air temperature. It's worth noting that using a non-genuine engine block heater can have negative effects, interfering with the proper thermal regulation necessary for accurate sensor readings. Other complexities, such as wiring issues, poor connections, or even software glitches in the PCM, cannot be overlooked. Hence, thorough diagnostic procedures should be employed to investigate these potential causes methodically. When DTC P011A is active, several symptoms can manifest, adversely affecting vehicle operation. One of the most immediate indicators is the illumination of the Malfunction Indicator Light, MIL, serving as an alert to the driver that there is an issue requiring attention. Alongside the MIL, the vehicle may exhibit reduced performance characteristics, such as sluggish acceleration or stalling. The potential for decreased fuel economy can also arise because the engine may become inefficiently programmed to manage fuel intake without reliable temperature data. Moreover, incorrect readings could lead to engine overheating, posing severe risks if not addressed promptly. Drivers might also notice unusual engine behavior, including rough idling or abnormal temperature fluctuations as the vehicle operates. Early diagnosis and repair are crucial to prevent further complications associated with this error code. The first step in troubleshooting DTC P011A involves preparing the vehicle for diagnostic evaluation. You need to turn the ignition switch to the lock position or use the engine start-stop button to select the off mode. It is essential to wait for at least 6 hours to to allow the engine temperature to normalize with the ambient environment, helping to ensure accurate readings when beginning the diagnostic process. After the waiting period, start the engine and let it idle for at least 10 seconds. It's imperative not to use an engine block heater prior to this check. Using one can affect the engine coolant temperature stabilization, skewing the results obtained from ECT sensors. This initial step creates a baseline for the sensors to be assessed accurately, which is crucial for subsequent tests. The second troubleshooting step requires checking the stored freeze data, which can provide insights into the conditions when the DTC was triggered. Evaluating the ambient temperature is essential, as the sensor's readings must be interpreted in conjunction with this external data. It's necessary to ensure the ambient temperature is close to the intake air temperature noted in the freeze data for a more accurate assessment. Pay close attention to the readings from both ECT sensors and the IAT sensor, as any significant discrepancies can indicate a malfunction. Moreover, it is crucial to avoid conducting tests in conditions of rapid temperature change, which could skew the sensor outputs and confound the diagnosis. Accurate evaluations within stable environmental conditions will provide the best chance of identifying the specific cause of the malfunction. After completing all necessary repairs based on initial findings related to DTC P011A, it is vital to conduct a final verification procedure. Begin by clearing the DTC and any associated freeze data stored in the Powertrain Control Module, PCM. This step ensures that old error codes do not interfere with future diagnostics. Next, test the vehicle over 3 successive trips to monitor the PCM for the return of the DTC. This process helps confirm whether the initial problem has been resolved completely. During these trips, the engine's performance should be assessed for any unusual behavior or indications of poor efficiency. If the vehicle operates smoothly, without re-triggering the DTC, it indicates a successful repair. It is critical to document all steps taken during the troubleshooting and repairing process to aid future diagnostics. Preventive maintenance is crucial for ensuring the longevity of the ECT and IAT sensors within your Honda Accord. Routine checks of the sensors will allow for early identification of any potential issues before they develop into significant malfunctions leading to trouble codes like P011A. Maintaining clean electrical connections is equally important. Any corrosion or debris can disrupt the signals sent to the Powertrain Control Module, PCM, affecting the engine's performance. Regularly monitoring the coolant levels will ensure proper operation, as insufficient coolant can lead to inaccuracies in these temperature sensors. It's also vital to use genuine replacement parts for any repairs or replacements performed. Genuine components are specifically designed to adhere to OEM standards, ensuring proper functionality and reliability every time. In summary, DTC P011A highlights critical issues with the engine coolant temperature sensor 1 circuit, necessitating prompt analysis and resolution. The ECT and IAT sensors work in tandem to provide accurate engine temperature readings to the Powertrain Control Module, PCM. If discrepancies exist, they can lead to sensor faults, thereby triggering this DTC. A methodical approach to troubleshooting, starting from ignition procedures to evaluating freeze data, is essential for accurate diagnostics. Finally, integrating regular preventive maintenance will not only extend the lifespan of these components, but will also ensure the Honda Accord operates at its peak performance. By understanding the importance of these sensors and adhering to recommended maintenance practices, vehicle owners can prevent the recurrence of DTC P011A. Please like and subscribe to the channel. See you next time!